What's up, math fans? Today we're talking about quadratic equations and how to solve them. In algebra, you've probably learned what they look like. You might have learned some factoring methods. This method is called the quadratic formula. So first of all, you have to know what a quadratic equation is. A quadratic equation is an equation, so it has an equal sign. And you hear the word quad, you're thinking 4. It's not actually 4. Maybe geometrically it's 4. Quad is a 4-sided shape. So if one side is x and the other side is x and you're finding the area is actually x squared. So even though you hear the word quad, what you're looking for is the highest exponent is a 2. If the highest exponent of your equation is a 2, you're looking at a quadratic. If the highest exponent is 3, it's a cubic. If the highest exponent is only 1, that's a linear, that's basic algebra. So today we're looking at when the highest exponent is 2 and it's in descending order, meaning standard form. You'll recognize a quadratic looks like this. ax squared plus bx plus c equals 0. Again, people get upset with the letters. The letters are just placeholders. The a represents a number that's in front of an x squared. The b represents a number that's in front of just a plain x with no exponent. And then the c represents your constant, which means there's no variable next to it at all. And if it's in standard form, it's going to equal 0. And you'll see later, it doesn't have to be in standard form. We have the algebra skills to get it in standard form. Okay? So someone looked at quadratic equations like this, and they said, well, there's got to be a value for x, that when I substitute an x here, my equation will be equal to 0. And of course you can sit there and guess and check, but eventually they get a lot more complicated where guess and check is not a good idea. So someone sat there, and it's debatable on who figured this out first. Was it the British? Was it the Indians? And we're not sure. Was it me? So they decided that they would solve it by using what's called a quadratic formula, because factoring doesn't always work. Sure, you can factor this using the sum product method if you've seen my other videos. There are other ways of factoring. When you factor a difference of 2 squares, you look for a GCF, all that stuff can try to help you, but when all else fails, this works all the time. It's a formula specifically for quadratics, and here it is right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm sure if you Google it, you'll find some songs about it to help you memorize it. And again, I'm very specific. The b's and the a's and the c's, they all come from your given equation. Okay, so you're not putting x in the formula at all. You're only putting in the coefficients of x, the actual numbers themselves. Also, they emphasize all over 2a means don't divide by 2a right away. Make sure you do the entire numerator first, kind of like PEMDAS, and then the last thing you're going to do is divide by 2a. And here's some examples. Also, if you're curious, stick around to the end of this video, and I will attempt to solve this myself and show you where this actually came from. I don't want to put you to sleep right away. All right, first one, very basic quadratic formula. Yes, you can factor it. Yes, you can do guess and check. Yes, you can probably tell me the answer right away. But just in case you can't, we're going to practice the quadratic formula. So first I need to identify what is my A, what is my B, and what is my C. A comes from here, and A equals x squared, right? No, that is a rookie mistake. Don't tell me A is equal to x squared. A represents a coefficient. A coefficient is a number, not a variable. What number is there? It's a hiding 1. What's B? It's 3. What's C? It's negative 10. Don't tell me 10. It's negative 10. That sign has to come along with it. So then, I highly recommend you write the whole entire equation again. Since I've already written it, I'm ready to do substitution. So x equals negative b is negative 3 plus or minus square root of b squared is 3 squared minus 4 times a times c. Okay? Times a is 1 and times c is negative 10. All over 2a, and 2a is 2 times 1. All right, from here, it's simple PEMDAS, order of operations. So make sure you know your order of operations first. What am I doing first? I'm going to do what's in the radical because that's considered parentheses to me. What is inside the radical is a bunch of stuff. So let's see, negative 3. Some people don't say the word negative, they say opposite of 3, and you'll see why in a minute. You'll see why in number 3, I believe. Because what if b was already negative? It becomes positive, so opposite. Negative 3 plus or minus, because the square root could be positive or negative. 9 minus, so I did exponents from PEMDAS, I did the exponents, and now it's okay to also do the multiplication, because I already did the exponents. Next is m for multiplication. So 4 times 1 is 4, times 10 is 40, but that was a negative 4. Pay attention, that sign is always a minus, or negative makes it 4 negative, and negative 10 is plus 40. All over 2 times 1 is 2. Still simplifying, I have negative 3 plus or minus 49. Now I can add what's in the parentheses, and it's still all over 2. X equals negative 3 plus or minus 7. Square root of 49 is 7. 7 times itself is 49. Still all over 2. Too many people like to divide right away, especially if this is an even number, they're ready to divide. If this came out to be an 8, they're ready to do 8 divided by 2. No, we're still doing the top. So x equals negative 3 plus 7 over 2, or negative 3 minus 7 over 2. That's what this symbol means. Plus or minus means it's actually 2 different problems in one. So I need you to tell me the answer when it's plus. I need you to tell me the answer when it's minus. So here, negative 3 plus 7 is what? 4. 4 divided by 2 is 2. So x could equal 2. Or, if I had negative 3 minus 7, that's negative 10. 10 divided by 2 is 5, so that's negative 5. And those are my 2 possible answers, which yes, you could have gotten from factoring or even guess and check. Take the 2, plug it in the original equation, and you'll see that 2 squared plus 3 times 2 minus 10 does equal 0. And you also want to try for the negative 5, okay? And that should work as well. I'm not going to do the check. You're already advanced. You know how to do the check. Any questions, put them in the comment box. Let's move on to a different looking one with different answer. Different type of answer. These are considered real, rational, integer answers. You don't always get that. Next one, identify A, B, and C. What is my A? It's nothing, which means it's 1. There's a 1 coefficient here. What is my B? There's no coefficient of x. There's no x term. When there's no term at all, then the B is 0. And what is my C? It's that that constant that I said earlier. That's a 9. Okay, so we'll do it again. X equals negative b plus or minus the square root of b squared minus 4ac. Extend that a little bit, all over 2a. Okay, when you get better at this or quicker at this, obviously you don't need to put the 0. There's no difference between positive 0 and negative 0. 0 is neutral, so this is going to drop out anyway. And now I have positive or negative 0 minus 4 times 1 is 4 times 9 is 36. All over 2. So that's the positive or negative square root of negative 36 over 2. It looks a little bit cleaner than the last one, but you remember now there's no such thing as a square root of a negative number in the real number system. So we have an imaginary answer, positive or negative 6i over 2. Okay, so for you to understand imaginary numbers, you might want to see my video on imaginary numbers. So this is quadratic formula, works for real numbers, rational numbers, imaginary answers. You'll also see irrational answer in a minute. So this, of course, simplifies 2, 3i, positive or negative 3i, imaginary 3. Some people write it separately as 3i, x equals 3i, or negative 3i. 2 different answers separately. You can use the symbol as well, same thing, okay? Finally, the last one. You have to recognize there's an equal sign, so it's an equation. The highest exponent is 2, so it's definitely a quadratic equation, but it's not equal to 0, so it's not in standard form. We must put it first in standard form. How? Well, just make the right side, or either side, doesn't matter, equal to 0. I like to make this side equal to 0 because my positive x squared was already on the left side. So I subtract 6x on both sides. Notice 6x is not a like term with anything else, so it just drops down. And I have, I don't know if you can see that, yes you can, 9x squared minus 6x minus 11 equals 0. So you have your A, your B, and your C. A is 9, B is negative 6, and C is negative 11. So x equals negative B. Remember what I said, the opposite of B, negative 6, is really positive 6. You don't have to show this, I don't think, depends on your teacher. But a double negative will get you a positive, so you don't have to write the double negative. Plus or minus, square root of b squared is negative 6 squared, minus 4 times 9, I hope you can see this 4 here, 4 times 9 times negative 11 all over 2a, which is 2 times 9. Whew. This is a lot of work. Be patient, you'll get there. I know there's a lot of room for error as well, so don't rush through it. We said that was positive 6 plus or minus the square root of 36. Negative 4 times 11 is 44 times 9. What is that? 36, another 36, 39. 396. 396. And this time it's positive because negative times negative is positive. All over 18. X equals 6 plus or minus 396 plus 36 is 432. 432 all over 18. Depends on your teacher. If you can leave it like that, you're done. You got your 2 answers. You might want to simplify completely, depending on the directions. If that's the case, now you need to have a different lesson on how to break down a radical. You want to find factors of 432. It might take you a while to get a calculator. Tell me what perfect square and another number multiply together to give me 432. And I think the answer, 432 is divisible by 3, and you get 144. So it's 144 times 3 is really 432 all over 18. That's helpful because now x equals 6 plus or minus 12 radical 3 over 18. And again, depends on your teacher. Do they want you to simplify all the way? Then there's one more thing you can do. Find a GCF. 6 goes into the 3 coefficients, or the 3 constants, excuse me. So 6 goes into itself once, 12 twice, and 18 3 times. So my final answer is 1 plus or minus 2 radical 3 all over 3. All right? Actually, I'm not going to extend this video by doing the proof, although if there are any requests for it, I'll make a separate video. Thanks for watching. See ya.